And if you recall from example 4, we were right here. All we need to do now, well, we'll straighten that out and integrate something to the 3/2. The final answer should look like this. And by the way, this final answer, you could have actually solved it using double substitution, dub sum. However, since we're doing lessons on integration by parts, I thought, why not teach both ways? Maybe you'll like one better. Okay? We've got one more type, and then we'll look at multiple integration by parts, tabular method. I think my third major tip, first, look at Liate to tell you what U is going to be. Second, if there's two algebraic parts, make the more complicated portion equal dB. And then finally, the third tip that I'm giving you is if you see only one type of function there, just log, no others there, let dx equal dv, meaning that one section there is going to be u and this part is going to be dv. Here's what it looks like when we break it down. So you've got u, you got dv. We take the derivative, we take the integral. We know that this should now, the integral of u times dv is going to be equal to u times v minus v times du. This simplifies wonderfully, and we should finally get an answer knowing that the natural log is x log x, oh, that's just 1, minus the integral of 1. That is an integral that you can memorize. You can just learn that the integral of log is equal to that, but I recommend just using integration by parts. And for a quick bonus example, the other time you might see one particular type of function is maybe with the inverse trig. If you see an inverse trig, once again, there's only one function left, dv equal dx. We plug it in, and we have u times v minus v du. Great. U substitution over here on this other side, letting u equal 1 minus x squared. And if you don't believe me, stop and check it out. That's it for the integration by parts examples. One more video on integration by parts, how to do it multiple times, called tabular, coming up. Thanks.